Hello everyone, welcome back to another video. Today we are going to be discussing a problem on inverse trigonometric functions. Okay, so let us begin. So we have been given an expression, we need to find its value. That's it. So looking at the first expression, this one, don't you get the idea of an ellipse? But the equation of the ellipse is somewhat of the form this thing, right? X square by a square plus y square by b square is equal to 1. But we don't have the term 1 over here. So what do we do in order to bring 1? So what I thought of was the domain of sine inverse, all right, that like the this value must belong to minus 1 to 1. Okay, since this value is clearly greater than equal to 0, I'm using only this condition, x square by 4 plus y square by 9 less than equal to 1. So this doesn't it represent the equation of like the inside part of an ellipse? It does, right? Now, since I use this idea, the idea of domain in this expression, I'm going to use the same idea of domain in this expression, the one inside cos inverse 2. So let us do that. Okay. So x by 2 root 2 plus y by 3 root 2 minus 2. So here, like we do not have any leads. So I have to use both expressions. Okay. So this will yield us like two lines, right? One would be x by 2 root 2 plus y by 3 root 2 plus 1, no, not plus 1, minus 1 greater than equal to 0, and one would be x by 2 root 2 plus y by 3 root 2 minus 3 less than equal to 0. So these two, like this whole equation, like including these two lines, it represents the area between two parallel lines, right? So let us now draw the diagram and see what happens. So I'll be drawing the diagram now and we'll be seeing what happens. Okay. So what I got the feel of was that like let me test whether one of these lines is a tangent to this ellipse or not. Let's just let me test. Okay. So the line closer to the origin would be this one itself, right? So I tested with this one. What is the like? How do you find the equation of tangent of an ellipse? It's something like x1 by a square plus y1 by b square minus 1 is equal to 0 form, right? This form only you get like tangent, right? So I tried to compare it with this form and test whether the point lies on the ellipse or not, and it worked. Okay, so what I substituted like x1 as was x1 by a square is equal to 1 by 2 root 2, right? Or I'm just comparing the equations, and from here I get x1 as root 2 and y1 by b square is equal to y1 by b square is equal to 1 by 3 root 2, right? B square is what, 9. So my y1 comes out to be 3 by root 2 something. So I just tested out whether it satisfies the equation of ellipse or not by substituting it, and it does, all right. I can show it to you also. 2 square by 4 is 1 by 2, and plus it would be 9 by 9 by 2 times 9, and of course this would be equal to 1, so it satisfies the equation. So I can say that this line is tangent to the ellipse. Okay, so this line is tangent to the ellipse and it intersects at, okay, you would have read about this form of a line, x by a plus y by b is equal to 1, right? You would have read this form of the line, right? So I'm using that form itself. So it intersects the axes at 2 root 2 comma 0 and 0 comma 3 root 2. Why am I doing this? You'll come to know. So I'm doing this to find the relative position of this line with respect to this line, all right, with respect to this line. So if I use the same form over here, I'll get like the coordinates as points where it intersects the x-axis as 6 root 2 comma 0 and 0 comma 9 root 2, all right, which are like which is fairly above this line, okay. So what I get here is this region, okay, between these two parallel lines, and my other equation yields this region. So the region, like the point in common is like a single point itself. The region in common is a single point itself, which is this line, that is the point of contact. So I can say that the value of my x would be like the solution of the equation would be the ordered pair, I mean x by x comma y, the order pair of my solution would be root 2 comma 3 by root 2. Okay, so let us substitute it and find the answer. So this thing will become, let me use a different color. This thing will become, as we saw earlier, 1 itself, because the point lies on the ellipse. Okay, so this will become 1 itself. So this sine inverse term would be, pi by 2. Okay, and coming on to this term, since it satisfies this equation, look at it. Since this point satisfies this equation, this one over here, then I can say that x by root 2 plus y by 3 root 2, x1 by 2 root 2 plus y1 by 3 root 2 minus 1 is equal to 0. Okay, so here we'll be left with minus 1. In this bracket we'll be left with minus 1. Okay, what is cos inverse of minus 1? The value of cos inverse of minus 1 would be, this bracket would yield cos inverse minus 1. The value of cos inverse minus 1 would be pi. So my final answer would be pi plus pi by 2, which is 3 pi by 2. Option D.